This presentation is entitled Digital Libraries, What are the Foundations? We had a few readings assigned, and many of them are sort of set the story for why do we need digital libraries, who thought about them before we really even had the term digital library, and some of the contemporary problems we have with them, and also the successes. One in particular that we're going to have a discussion and exercise about is Vannevar Bush's As We May Think. Perhaps some of you have come across this reading before in another class. I can't remember where I first read it, but it's amazing how ahead of his time he was. Bush was worked in, during World War II, worked for the government, and then after the war was basically tasked with how do we, tasked himself, I don't even know if someone told him to do this, it was him really seeing this problem that we have all this knowledge but really no way to access it in a, using human eyes, using our normal typical ways. We need something to automate our access to all this information. So all of we have all this knowledge created, but what way can we use technology to access it? Well, some of the problems that I just mentioned, there was too much knowledge, too much information rather, to access in conventional means. Scientists were creating all this knowledge and all this research and couldn't communicate across disciplines. Over-specialization, you could no longer be a generalist, so this is just some of the things that were happening in the field of science, but many many academic fields. The era of the, say, lone wolf scholar, someone like Gregor Mendel, or trying to think of other ones, all the scientists, Darwin, all these scientists who basically just operate on their own, maybe with a microscope, maybe they'd have a lab assistant, but basically that era was ending, and because science was getting so complicated, you needed basically teams of researchers. So the more people you have involved in research, the more communication that needs to take place. And oftentimes, and that's the case today, where you have basically scientists that are operating across disciplines. So Bush could already see this happening, and indeed this has happened today. For example, if you were to look up almost any research paper in the sciences, even libraries and archives and information sciences, it's rare to see a single author publishing. You're almost always going to see a co-author. If you were to look in Science or Nature, that magazine, those journals are to the extreme. You'll look at an article, a research article that's been published, and you might see 5, 6, even 10 authors that are involved. So Bush could see this complexification, if you will, of knowledge, and so the means that were used in the past to access that information were no longer really working out. So some of the solutions he came up with, now some of these are kind of funny because you see pictures or you can kind of imagine, but he had this idea of a mini camera. It would be like a walnut size sort of lens, if you will, that would be on someone's head, and they could basically scan information using that. He had this idea of dry photography. That term sort of sticks out there, like what does he mean by that? Basically it just means that photography, it doesn't need to be developed. Well, we already have that today. Many of these things I'll point you to, and I'll let you hopefully do some of the research on your own, but like dry photography would be basically what digital photography is. There is no developing, if you will, of the image. There's no negative or any kind of darkroom that needs to happen. It's just a digital printing of it. He keeps talking about compression or miniaturization. That's one of the things that really the 20th century and the 21st century has been all about with information. Really, it's been the history of information. Since books came about, we were able to basically pack a lot of knowledge into a very small form factor. Well, that form factor has been getting smaller and smaller to the point where we're, on the atomic level, or on the, of basically charging particles and making zeros and ones. We have a binary way of storing information. I'm getting a little ahead of myself. We'll get back to that in a minute. But we think about the title of the article, and I have to say it took me a little while to really kind of wrap my mind around it, no pun intended, as we may think. But some of the ideas he was getting across with that title was, how do we get machines or computers to think more like our mind rather than like say a machine or a factory assembly line where one thing is built and then the other thing is built and so on and so forth. The mind doesn't operate that way. It operates in a much more complex way. So as we may think, was that title was sort of making a nod towards that. And then the other thing we have here, and this is some of my own thinking here, but how do we do things with math or with letters? And so when we think of that, how computers work, well, they need programming languages. We need ability to take text or images and turn them into things that computers can read. This is all stuff that he was thinking about, but he really couldn't put it into words because the technology didn't exist. But we'll talk about this later in the course. We'll talk about OCR, which is optical character recognition, natural language processing, text mining, and so forth. The class is not going to be about that. We're not going to really use that per se, but these are some of the things that have made digital libraries possible. So let's pop out of the presentation just for a second, and we're going to go to the website. And I just wanted to start here at home. We're on the course site, and I have the exercise lined up for you. What you're going to do is just click on it here, or you can go actually from the discussions if you wanted to and start there, but I'll just start you from the course site. We'll click on as we may think, and this is a hyperlink, and basically you'll have a little description page of what you're going to do for your exercise. This is your exercise. This is basically worth 1 point. I've gone over this in the syllabus and a little bit in the video, but if you do this assignment, it's really not an assignment, it's just an exercise to take place of what we would have done in a face-to-face class. You get a point. There's 15 points for exercises or / discussion. I'm not going to go through all this, but basically in 150 words, or excuse me, 75 words, I just want you to answer one of these questions and post it to the discussion board, and then you're going to comment on one of your classmates. Just one comment is good enough. I want you to put your best foot forward with this. Answer it. It shouldn't take you more than maybe an hour or two to work on this. And then in the discussion page here, you'll create a thread and answer one of the questions there. And then as your classmates come in with questions they've answered, you can comment on one of them. And that will be the exercise for week 2. So I'm going to go back to the presentation now.